Welcome back, my darlings. We are now looking at section 1.2, day 2. We're going to be focusing on domain, and we're going to do a little preview of something that's used in calculus, as this is pre-calculus. But starting with domain, when we look at domain, we're going to look at these two specific red flags, fractions and even roots. Has to be even. So think about if you're using your calculator and you try to divide by 0, it tells you error. You can't divide by 0, you get an error. So anytime we have a fraction, the denominator, the bottom part, cannot equal 0. Well, think about even roots, like the basics, square root. Square root of 9 is 3, square root of 0 is 0. But if you were to try to take the square root of -9 on the calculator, again, it says error. You cannot take the even root of a negative number. Odd roots are fine. Cube root of -8, -2. So the only time we have to worry is if it's an even root. So square root, fourth root, sixth root. So if we have an even root, this stuff underneath has to be greater than or equal to 0. For now, and again, those are key words, for now, everything else is all real numbers. You can either write the words or this is the symbol for all real numbers. Later on, we will get functions that also restrict the domain, but for now, the only two things we're worried about are fractions and even roots. So example 1, find the domain of each function. So A, I look at this function and say, do I have a fraction? No. I look at this function and say, do I have an even root? Yes. So the thing underneath cannot be negative. So 2x minus 3 is greater than or equal to 0. So add the 3, divide by 2. Our domain is all real numbers such that x is greater than or equal to 3/2. All right, so for B, I look at this function and go, ooh, do I have a fraction? Yes. Do I have an even root? No. So all I have to worry about is the fact that I can't divide by 0. So the denominator, 2t squared minus 18 cannot equal 0. So add 18, divide by 2, take the square root of both sides, and t cannot equal plus or minus 3. Plus or minus, remember, anytime you yourself take the square root, it's a plus or minus. So domain, all real numbers except t cannot equal plus or minus 3. All right, so C, I look at my function. Do I have a fraction? No. Do I have an even radical? No. So for now, everything else, all real numbers. I look at my fourth function here, and I go, ooh, do I have a fraction? Yes. Do I have an even radical? Yes. So I have to worry about both of these. The denominator cannot equal 0, and this stuff inside the radical has to be greater than or equal to 0. But it can't equal 0 because it's in the bottom of a fraction. So I get 3x plus 1 is greater than 0. So subtract 1, divide by 3. Domain is all real numbers such that x is greater than -1/3. All right, so example 2 is our little preview into calculus, and we're going to evaluate something called the difference quotient. So we're going to use this function f. So it's going to be similar to what we did on the previous notes. We're going to evaluate functions, and then we're just going to do these operations. So first, I want to find f of 3 plus h. So if I plug that in to this function, I get 3 plus h squared plus 2 times 3 plus h minus 3. So I get 9 plus 6h plus h squared plus 6 plus 2h minus 3. Combine like terms, and I get h squared plus 8h plus 12. Please remember you cannot distribute an exponent, cannot. So 3 plus h squared is 3 plus h times 3 plus h, and when you FOIL that out, you get 9 plus 6h plus h squared. All right, now I need to find f of 3. So I plug in 3 to my function and get 3 squared plus 2 times 3 minus 3. 9 plus 6 minus 3 is 12. And now I'm going to actually evaluate the difference quotient. So I take the first part, h squared plus 8h plus 12. I subtract the second part, minus 12. And then I divide by h. The 12s cancel, so I get h squared plus 8h over h. Both of these are divisible by h, so I'm left with h plus 8. And that finishes it off. Have a great day.